our last sessions. So before I start the CFD, today I want to say this: nobody in this CFD we should know that why we use CFD and why CFD is coming, and is aeronautical that degree is important, or is enough for us, or we need to learn another thing, another design. See, nowadays, if we say if I taking aeronautical degree or mechanical degree, apart from this, we need some design analysis, because of in nowadays we need to survive with designing, with analysis. You need to, your basic skill should be in your mind. Behind this, we need analysis and designing skill. So CFD is the one of the part. See, in that CFD, we are doing like experimental work. If we start the research, in the research we are doing either experimental or other analysis. In this CFD, there's two things we need to know that in CFD in use. One is the analytical fluid dynamics, and another is the experimental fluid dynamics. Here we can see is computational, and there's a fluid, F for fluid, and D for dynamic. What is computational? Computation is the help of, input data. If you supposed to, if you, I think you guys know that studied a C, C++, that computer. So in that we are putting input and some processing, and after that we get output. This computation is like input data with help of computer. And fluid. This fluid is a substance, deforms the applied shear stress. It could not resist. It can be moved with shear stress. Here you can see dynamics. In dynamics is the branch of mechanics that concerned with the motion of bodies under the action of force. We know that we already we know that fluid dynamics, because of every if you go if you take a morning tea also is type of fluid dynamics. That also CFD also applicable. Rainfall, and you know that lake, dam, and the rocket movement also, that CFD is also applicable. So next slide. What is CFD? We'll discuss somewhat. So here we can discuss briefly. CFD is predicting something, predicting with is like a fluid flow, heat transfer, mass transfer, chemical reaction, or related to phenomena by solving the mathematical equation. In that, suppose if you design anything, any product, or any if you think aeroplane, you are going to design aeroplane, because you cannot experiment aeronautical aeroplane full. So in that big product, or before manufacturing, we need to know that this product is going to manufacture, and it can be supply in that public. So before, so we need to do CFD. So in this CFD analysis is relevant to engineering data. They are using the conceptual study of new design, details product development, troubleshooting, redesign. These four things are very important in CFD. So we need to know what's the conceptual study of new design, right? Actually, when we are something, we are in that where mind is creativity. It's like invention thing. We first, once we are going to do anything, we first imagine in our mind how it look like. Is this thing also. It's like conceptual study of new design. See, new design like a design concept. Okay, define and describe the principle and engineering features of a system. This is maybe machines or a component which is feasible and which has the potential to fulfill the all essential requirement for design. Here you can see in second thing, it's a detailed product development. This is typically referred to all the stage. Once you complete your design, then it's come to develop how to develop this design. In this, we involve to bringing a product from concept or idea. So third thing is troubleshooting. See, anything if you are going to do, there's something negative thing will be there. So in troubleshooting, we need to identify the problem solving, and with that in apply to repair the failed product or process or machines or systems. It's need to identify the symptom. It's identify the why is that problem issue is coming in that product. Then this symptom we need to identify and we need to resolve it. Just if supposed to that problem is not solving, we are going to redesign again. Again, we have to start the conceptual study, then new design and development product. We have to, as a circle, we need to do it up to get the satisfaction result. In this CFD analysis, complement testing and experimentation. Reduce the total effort required in the laboratory. See the how to CFD's process going on in circulations system. We can easily identify. See, as the first problem is fluid problem. We have a fluid problem. To solve this problem, so we should know the physical properties of fluid by using fluid mechanics. Okay, so in that picture you can understand easily. Then we can use the mathematical equation. Okay, so in this physics fluid, I just described this physics fluid. Sorry, actually physics fluids. Okay, it's a fluid is a liquid or a gas. It can be form of liquid or gas forms. For example, water and air. Fluid has many important properties. That's density, velocity. So such a velocity and pressure, it may be temperature, density and viscosity. The density of a fluid is its mass per unit volume. If the density of fluid is constant or the change the very small is very small, we can call the fluid is incompressible fluid. Suppose is that velocity is density is constant means that we call this fluid incompressible. This fluid is incompressible. If the density of fluid is not constant, we can call the fluid is compressible. So normally we can treat water and the air is incompressible fluid because we know that the density is not a constant. Okay, so water and air is incompressible. Let's come to the Navier-Stokes. See, then we can. So in this Navier-Stokes equation, and it is a governing equation of CFD. As the Navier-Stokes equation is analytical, and see, human can understand it and solve that problem is one piece of paper, and that come to a discretized form. But okay, but if we want to solve this equation by computer, we have to translate it to the discretized form. Discrete form, like in that we can finite difference and finite elements and finite volume method. Now come to the grids. See, we also need to divide our whole problem domain into many small parts. because of our discategorization is based on them. Then we can write program. We can write a program language in that computer program, and we can to solve that problem. Then typically language are the what one is portion or C plus. You all know that is C plus plus Python, MATLAB programming. So in that type of program, we need to we need to create and we need to solve this problem. Normally, all the program are run on workstation or supercomputer. At the end, okay, at the end we can simulation. We can get our simulation result. We can computer and analyze the see in the computer after analyzing. So in simulation result, the experiment and the real problem we compare with the simulation result and again with the experimental result. So if the results are not satisfied to solve the problem, we have to repeat the process until find satisfaction solution. This is CFD process. So overall, we can see in that circulation circle, if this process are going through and get that result, if that result is an analysis result, and again we are going to do experiment result. For that, get the answer, compare the analysis answer and experiment answer. If it's equal, then we will get successful result. Next, why use CFD? If I compare CFD experiment, CFD is a simulation and experiment. Its cost is cheap. CFD cost is cheap and the experimental expensive. Because of if you go experimental way, we need to arrange all equipment and we need to check all system is there available or not. This type of you need to buy another thing, another equipment. What are equipment are you applying the experiment, and that is too costly. So in the simulation CFD, we can see it's cheap because of no need to buy anything. You should know the CFD programming and CFD analysis. Then you can find out that result. Timing also short timing. No need to go anywhere, any workshop, anywhere. You can do it your home using CFD. And excellent, you have to go that workshop. You have to arrange everything. If you don't know, you have to hire some expert. Those are helping to you complete your problem that experimental. So this is one time of long process. And even it's a scale. In any scale, you can put in that CFD in that programming. In the experiment, small and middle, because small and middle product or middle problem you can solve. But if you think aeroplane, if you think train and ship, you cannot experiment, right? So that's why you need to do in CFD. In that information, in once you design and develop that designing and solve that problem, that you can get all data like what the pressures, velocity, and temperature, density. You can find out on one of that one safety. In experiment, you have to measure the separate point. You have to find out the density, pressures, temperature. You have to do the separate experiment. So let's see. Oh, in security purpose, this is safety. Because of safety, is only you have to do in that supercomputer, and experimental is somewhat dangerous because of there's a wholly manual process in experiment. So it's really be careful because of some you have to take situation before you start the experiment analysis. Is it safety is good? Yes. If you see in that Field articles, it's actually 1987 is published on the articles. He wrote it that the computer is attractive as a replacement of experiment that are difficult, dangerous, or expensive, and as an alternative to experiments that are impossible. It's really right? Because of you cannot accident whole uh, product or whole problem because of I already described what the actually easy to easy process. So in CFD, we would agree to be the first person to vote in aircraft design purely through CFD. Actually, fully designing aircraft using only CFD. Okay, in CFD, we can see it's not in aerospace. You can see in mechanical, chemical, civil, and several industry. See, no one escaped from CFD. No engineer he has to must be using CFD because of analyzing and to getting the satisfying result. So aircraft design, missile design, launch vehicle design, nuclear reactor design, process industry everywhere. So in that CFD has no has now assumed a broader meaning. So in chemical reaction, we can see that boiler in that chemical reaction for cooling purpose also safety analysis required in fluid structure interaction, multi-phase physics, acoustic and variety. Of other physical phenomena also safety can use. Why should we know its history? See, without history you cannot judge anything, right? You should know that history of the any product or anything. If you buy something, so you need to know that what the history of this which company belong this product. So you should know the history. It is not important to know that and pay travel tribute to these gains. Also, knowledge of history given a wider perspective help us avoid error and make us more humble. See, base of CFD. In CFD, we can see naval stock fusion. In this, you can I'll describe it better in video. In this safety, neighbor stock is very very important this equation because of problem solving process. Here you can see the four components density, velocity. So we need to find out that for equation. It's a narrow number. So you can see in narrow number there's a two portion. You can easily understand. In narrow number you see. So one and two section. One is the control volume, one is the system volume. What happened in Reynolds transform theorem? And see, in this theorem is related to the system concept to control the volume concept. Okay. In that, this is the constant volume. We can see in that, look at the image below. See in image. In this image, we have a fixed control volume. See in the surrounding, we can see in the fixed control volume. This is not movable. With a one dimensional. In this section, we can see the control volume is between two sections 1 and 2. At the current time t, the system that we will consider the specific control volume. Okay. So in the system, we have hereafter with a short time duration t plus dt. Okay. In this system, we'll move slight towards the right. Okay. That control volume is already fixed and the system are moving slight towards the right side. As a result, the fluid particles that originally considered a section 2 and have moved to the right side. So in that we can see in that equation, this system equation, total system, and is that this system is it's a added of control volume and control system. In that rho density, and this is that any particular property that by any particular properties it may be mass equation it must be mass, energy or momentum. So it will be consider. Okay, next slide we can see continuity equation. This is also most important in continuity equation. We know that rate at which mass and enter a system is equal to the rate at which mass is leave the system. This is totally accumulation. No, see, in mass, this is not destroying. It only transferable. Once mass enter in system, is when that leave that mass is leave the system. This is the accumulation of mass within the system. Okay. See, in this you need to describe all equation. See, incompressible flow. We'll discuss later. See, in properties, see the fluid properties of flow property. In fluid properties, we can see density, dynamic, viscosity, kinematics, viscosity, specific heat, coefficient of thermal conductivity, thermal diffusivity. And if you compare with flow property, there is only velocity, pressure, temperature, and vorticity. Vorticity. See, we can here in this video, I can describe you. Here you can see colorful design. There's lots of uh, portions there in colorfully. In commercial fluid dynamics, is totally is analyzing and showing that that defines colorful. And here you can assume that one object is going to do that analyze. There's inlet, wall, and there's a control system in that outlet side. Then in that we need to find out the viscosity, velocity and pressures. That equation we need to derive. We need to find out that U, V, W, and P. That we need to derive. We need to find out that all result from this. If you know in this X, Y, Z, and T is the time variant, and this fourth section you can see 4. If you find out this all 4, then CFD I think will give you over, because of this 4 equation is most important to solve the U, V, W, and P. In we can see if we are taking one part of that piece in that whole component. See, once we just solve this equation, in that we need to know conservation mass. First equation, we need to find out the 4 equation to solve this Navier-Stokes. Okay, rate of change the mass in the volume is equal to inlet mass flux or outgoing mass. See, in that equation, see, this is the first equation we can find out. The next is the conservation of momentum. This is the related to Newton's second law of motion, and there's so 3D motion is 3-dimensional. So in here we can find out the 3 equation. This is the first equation, and second equation, the third equation. Then newly we get 4 equation. In this 4 equation, we are called is Navier-Stokes equation. So in this Navier-Stokes equation, we need to find out the U, V, W, and P. See, that the analytical solution example here, so it does not like a Navier-Stokes. Some analytical solution example. See, it's a non-analytical solution for NS equation. So in this curve, you can see it's a numerical solution. The one is Excel solution or one is numerical solution. In that numerical solution, we have to finite element method, finite difference method, and finite volume method. In here you can see numerical method plus NS equation is the DNS. DNS is like a direct numerical solution. This is highly accurate result. DNS are providing highly accurate result. It's not if you are going to analytical thing, if whatever supercomputer you are use, it gone along. That your result will be go error. So we need to direct numerical solution. We have to solve it. See, in next session, in next slide, you can see different analysis. You can see this in this picture. Here we can see some red dotted here, red dotted. This is called catastrophic failure. That means It may be if you before start production manufacturing, we need to solve this characteristic failure. This is your maximum failoreness is there because of some design issue or some development and programming issue. You can need to solve, or else it go during that flight is go. Break that portions. So before manufacturing, we need to find out that all problem solution. This is the CFD analysis, CFD simulation. You can see we can find out that where which portion that is problem. We can find out easily. Okay, using the CFD. Next, we can see different analysis. We can find out the pressure. We can find out velocity. We can find out the temperature using CFD analysis. Where is CFD used? In aerospace, automotive, biomedical, chemical processing. Is that AC? You can see that refrigerator AC and hydraulics, marine, oil and gas, power generation, sports. So how it is used in that field? See, in aerospace, we can see just after analyzing, we can find out that these portions we can see in that wing, these portions that wind steam are applied more. So if we can identify and we can solve it. See, in that automotive, we can find out that which part of that car that force wind steam or force is very high, and they affect in that which part of that body is more effective. So we can easily find out that using CFD analysis, because of say there is some color. In that color, they are showing the different identifications. In biomedical, see in the biomedical also, let's see in that how that blood is flowing, and in that nerves are brain, why is the more pressure as give more pressure. So we can find out that using CFD also. We can easily identify that which portion that more effective. So you can easily identify. In chemical process also, there's a different color which mention different activity. In that red portion, they are showing that there's a more pressurized or more velocity or more temperature are created. And you know that refrigerator, AC, and once you go and any mall, you will feel cool. But in behind this, in that system, we can see that is cooling as outing, and in that system, which portion is temperature high and which portion that pressure is very increasing. So we can find out easily, because of in that total whole system you cannot experiment. Okay, we can do it in that analysis. So even we can see that lake or dam. There is one of the switch gate is a control that all over lake water. So here we can suppose we control that dam. We need to pass out the some water. So here also we can find out that pressure, water pressure, was more effective. In that you can see in that picture, that's is more effective place. So we need to strong this place. In marine site, even submit or submit. There is in sea also, in depth of the sea. There are most pressure we cannot feel, but in that submarine there's sensor. They can analyze that overall pressure, deep sea pressure. So we can identify that in using CFD. And that in next is oil and gas. There also we can find out that problem, and we can design that like gas systems, that was that pressure is increasing, temperature increasing, intensity is more, then which portion are really effectful. Okay, So let's start power generation. In power generation, we can see in power generation sports. If we say think about the sports, you are aware, all are I think riding bike and cycle also. In that you can feel some force in front. You can feel in the chest. You can feel some pressure, and that we can identify that which portion in that whole overall. See in that if you think that backside you have the backside there's no any pressures are created in front side only, then which portion that pressure is created and how to that airflow is going. So we can find out in that CFD. See, I just what I taught you. I just give some question and answer. Please, there's a four question. Please try to give this answer. I give you 2 minutes. I think you can able to answer this question. In this, put the answer in the chat box. Okay. Okay. I request you everyone please write the answer in the chat box. The first question CFD is the method to calculate the heat transfer and fluid flow. There's four options: numerically, experimentally, intravenously, none of these. And second question, see at diastolic pressure, blood flow is what is turbulent flow or a mixed flow, laminar flow, irregular flow. I think you can easily find give this answer. In Reynolds number and velocity are see directly proportional to each other or inverse proportional to each other. Please give this answer. In steady flow, improved acceleration of any fluid particles is constant or zero or variable or non-zero. So let's check that anyone answering or not. Some of the people are answering. Thank you. So let's see. Just verify this with my answer. I show my answer with that explanation. See, first answer is numerically, and second answer is laminar flow. This diastolic pressure, blood flow is always laminar flow. This Reynolds number and velocity is directly proportional to each other. Once you go that derivations, Reynolds number, then you will get understand that. So in steady flow is a fluid, the acceleration of any fluid particle is always zero. So come to the CFD process. This the whole thing is have to do in the computer. If you know this process, then you can solve that problem. So in the sixth portion, sixth portion you can see one is geometry, physics, math, solve, report, and post processing. In that first of all, we know that geometry, physics, and math is both three things are is called pre-processing. See in geometry, we can have find out see that three types. You want to select the geometry parameter in domain, shape, and size. Once you open CFD software, first you have to find out that to select the geometry, and you have to put the geometry parameter, and you have to find the domain of shape and size. That what you are going to design. Is you have to find out the design. It could be rectangular, it could be hexagonal, whatever size you have to domain, you just put in geometry. In physics section you can see heat transfer is on off a choice in that that heat transfer is available in that safety or not in that problem solving. You can use on or off. You can push. Incompressible on off. Incompressibility, this product is compressible or incompressible. I already told you that what is incompressible or is compressible. Again, I recall you. This compressor is that density is not zero, and the incompressor's density is constant, or compressor is not constant. So which maybe you can put it in on off. In flow properties, you have to put that all properties. If you design that any aircraft, you have to that input as a density properties and pressures and air properties you have to put in and that flow properties and discuss model and boundary condition. In that boundary, everyone, the boundary condition and it's about the initial condition. You have to put in that physics portions. In mesh we can see once you complete your design, then you have to do it a mesh. It's like grid. You have to divide. It's your kind of divide and rule. If you suppose you cannot analyze whole thing, you need to analyze this small particle or small portions. Then that's why we are going to do mesh. Okay. In mesh we can see on structural and structural. In structural, suppose if it's simple design, then we can use structural design. If it's complicated design, then we use unstructured design. In structural design, it's maybe rectangular grid mesh, and you can see, or it's a square type. In unstructured design, you can find out that hexagonal pyramid type of unstructured grid mesh will shown. In CFD how it will work in that. Okay, in solve. Okay, before I go to solve, let's just show the one which I see. This is the totally physics, geometry, physics, and that is the only complete the design. And in mesh, these are mesh portions. We have to do it in that during that analyzing or in CFD. This CFD is somewhat structural design. See in that in the structure design, there's only rectangular. You can see, and here is the unstructural. See, there's no any size, same size. There's somewhat different size in that cube. You can see. Okay. Now come to that CFD process. In portion, you can see steady, unsteady. This is steady, unsteady flow, and we can know that iteration step and conversion limit that we have to select, and that's CFD software. In numerical scheme, you can see here. In numerical scheme, you can put that numerical. We have to study that Navier-Stokes equation. That numerical type of thing you have to put in, edit in that solve portion. Now, after solving, come to the report. Once you solve that design, you will find out that some output. In output, you can see in report. In report, you can find out the process post report. Once you leave drag, shear stress, strain, you can get. So after that, the XY plot, you can get one. You also get in report graph. This is type of XY plot. What you can find out. And after the verification and validation. See, this is the two main things we should know. Because of derivation, once you complete, you tell all the results. You have to verify all these things. Okay. Because of in derivation, we can verify with the accidental way, and validation we can validate that all over report. Is it correct or not? We need to find out. See, in that in validation, we need to compare with the accidental also, because of in accidental result and analysis is equal, then we can validate this report. Now come to the post processing. In post processing, we can see is a contour vector streamline. This which is just contour. What is actually thing? This contour plot is a color band. See, in that color band, we already told that there's a lots of different color. So different color are showing the different activities. In the control color band, plot of any variable where range of value is visualized by different color. This is good presentation of information, qualitative and quantitative format. So in second portion, you can see vector. In first processing, you already derived that three things: a contour, vector, and streamline. In that vector, we can understand that vector plot is a qualitative representation of spatial velocity vector colored by magnitude. Okay. The only limitation is that it can be drawn only on surface, be it a spline of 3D twisted surface. And come to that streamline. In streamline, we can see this is the very good representation of velocity field. At least two beginners of in CFD, it is very closely related to the velocity vector, and any inconsistency and may arise only because of post processing interpolation on a porous mass. Since theoretically explained in tangent and the streamline gives a direction of the local velocity field at the point. If you know the CFD process all over, then you can easily solve that problem. Now, come to that next session. In that, I already told that I show that picture. This is the first pre-processing in that CFD. This is satisfied that throughout the reason is a fluid properties model empirically, and is simplifying the assumption. See, in that we can see that order to make the problem tractable, there is a steady state, incompressible, indefinite, and a two-dimensional. In that we can find out the condition for problem, boundary condition. See, in that mass we can see how to create mass. In CFD applies numerical method. See, in this categorizations, in this question we can see that FEM, finite element method, finite Boolean method, and finite differential method. We have to do it in the discretizations to develop the approximation of the governing equation in fluid mechanics and a fluid region to be studied. Okay. In governing differential equation algebraic, we can derive the differential equation, partial differential equation is non-linear. So in that gate, in that collection of the cells is called the gate or mesh. See in that picture. In that picture, we are divided in cells, different portions and different sections, and we can easily analyze every portions. Then we can easily find out that while that any designing problem or any problems happen means it is shown by colorful. So some set of explanation equations are already solved numerically for the flow field. In this equation are solved simultaneously to provide solution. In this post processing, we can see that how that applicable in that CFD. We can extract quantities of interest in lift drag, heat transfer, separation point, pressure loss, etc. We can find out in that post processing section. See, now I show the example. You can see in the tube bank, you can see once water flowing at the tube in the water pipe. That flow is a two-dimensional, it's a laminar or incompressible. And in that, once passing that flow in tube, there is no any changes, and we can find out the pressure of the. We can calculation that pressure. We can calculate the temperature, and we can find out that way of path that water flow path. We can find out in CFD. In body force due to gravity are negligible. In the flow is translationally periodic, and this might be geometric. See, in mass generation, we can see in mass generation we can see a structure mass is placed around that cylinder to help to resolve boundary layer flow. In here you can see in that second in unstructural mesh there is no any accurate shape. This is it, I already told is maybe pyramidal or hexagonal type of shape it's shown in that mesh unstructured mesh. And we can see in cylindrical walls, see inlet and outlet, we can identify that pressure, and symmetry and periodic phase also we can find out that in mesh. Sectional mesh for tube tank problem, I can showing that in the picture. I think you can able to understand. And in advantage of CFD, we already compared with the experiment and safety simulations. We can easily find out that was the advantage of CFD. By say low cost. Yes, it's really low cost because of you are only doing this system only in computer, supercomputer. Not to go out and not to go in a workshop and not to buy anything, any equipment to for experiment. So in speed, this timing, the less time duration you can problem the solve. In ability to simulate a real condition. See in that theoretically simulate any physical condition, but cannot in that accidentally. See in that we can picture in that helicopter is lifting. There is some pressure in there, see then colorful. Then everywhere that every colorful are mentioning the difference effectful. See here in last portion you can see the red color because of in that portion pressure are very high. So in that experiment only permit data to be extract the limited number. In that pressure and temperature proofs and heat flux also thus see you can easily identify that all thing, and that larger number of location in that region you can find the location which location is affected, and you can set up the flow parameter of the examinations. See limitation of CFD is one of some limited area you can use in CFD. Is in if you think that physical models and you can see numerical error, some numerical error will be there because of the round of error. We can numerical find specified to two error is a round of error and truncation error. And so this round of error one type of that finite word size is available in that computer. This error is error due to the finite word size, and truncation error is one type of that you can numerical problem. If you don't properly solve the numerical problem, that error will be shown. So in round of error we can always exit because so they should be small in most cases. Truncation error is a go to zero as the gate is refined. So mesh and refinement is the only way to deal with the truncation error. So in boundary condition, we can see CFD simulation is only as the good as the initial boundary condition. In that, you can see in the picture is somewhat poor and somewhat better product. See in the computational domain, you can see in once the uniform inlet profile. Once after safety clarification, safety analysis, see somewhat better full develop that inlet profile because of initially we can see there is only initial inlet somewhat is state, and once we after analyzing we change that size because we already find out that these portions we have there is most problem here. Then after analysis we can easily find out, then we resolve it, then we can make it somewhat curve shape. So it's fully develop the inlet profile. In summary, we can, because I put summary because of this fluid dynamics is powerful way to modeling fluid. It's a heat transfer is related to process for a wide range, and in this time, CFD is very helpful for everyone. And in MATLAB also, in MATLAB side also, you can see that you can analyze this. So anywhere if you go, CFD is most important because of you see in that aircraft, in that missile also, how that missile launch, in that launch board also you have to analyze because of that temperature. We need to identify that what maximum temperature that launch pad can absorb. So this type of small cell thing we can analyze. So here is I complete my topic. Now thank you all are staying with me, and I'll explain how I just tour our college campus. So see this our okay. Thank you for the participant, and thank you to our head of department, and thank you. I really humbly thank you to my vice principals, principals, and college management. And anybody any doubt, you can call. And in that template, we are given that number, phone number, and admission number. Please share this information. Those are studying plus two or already completed plus two, and they are going to take admissions. Please share this information to every students. Thank you for staying with us.